think I still have it written down. So we did I equals PRT, okay, which we'll use here in a minute, and also future value, which was A equals P times 1 plus RT. So we're going to start with this right there and apply it to a slightly different context, okay? So when we did simple interest, we were talking about putting money into an account, or maybe you're borrowing money, and you just pay a flat, 6% for however many years. And then you multiply that out, and that's how much you pay, or that's how much you earn. Compound interest is actually where it's at as far as investing money, because you collect interest more than once, okay? So for example, we'll fill in the definition here in a minute, but let's say we have $1,000 that makes 10% interest, and we collect interest annually, meaning at the end of the year, we figure out how much interest has been earned, and that gets added into the account. So we can use the formula from the simple interest section, which was P and then 1 plus RT. Plug in the principal value, which is 1,000. 1 plus, what's the rate? 0.10. And time, if we're just doing 1 year, technically would just be times 1, so that's not really going to change it. And if I calculate that, what do I get? $1,100? Okay. So that's after 1 year. Okay. So now this is where simple interest and compound interest diverge and go off in their own separate paths. If we were getting simple interest every year, how much interest did I earn that first year, by the way? 100, yeah. So simple interest would just be $100 a year, basically. So if I did this for 5 years, I would just have $500 more than I did when I started. Compound interest, though, instead of doing it that way where you just add in 100 every year, you're now going to start over. And now it's like, okay, well, now I have $1,100 as my principal. And so that original amount plus whatever has been earned, now that gets multiplied with the same thing I did here, which is 1 plus 0.1. And just so that we can see the pattern and you can see where the formula comes from, this 1,100 was calculated from this formula, right? So I'm going to substitute 1,100 with what I actually did to calculate it, which was 1,000 times 1 plus 0.1. And now I still have this extra 1 plus 0.1. And now if we type that in the calculator, either the long way or the short way at the beginning, we get a higher amount. What is that going to be? So either type it in this way or type it in the long way. Either way, it should be the same. 1,210? Okay. And so right there you can see, if we were doing simple interest, we would have $1,200, right? Now we have an extra 10 bucks. And that extra 10 bucks comes from the fact that we're including those extra $100 now and getting interest on that the next year. And I think you guys can probably guess the pattern. Okay? So if this is how I'm calculating 2 years of interest, if I do 1,000 and I wanted to do 3 years of interest, how many of these would I have? 3 of them. So that's the same as 1 plus 0.1 to the third power, right? Rather than doing it the long way. So what do I get if I do that? $1,331. So hopefully you start to see, first year you earned $100 in interest. The second year it was $110. The second year was like 121. So each year you're earning a little bit more interest than the previous year. Now, if you do this for a long, long time, that adds up really quickly. Okay? If we just stop right now, well, then it's only like an extra 30 bucks or whatever. But over time, it does add up. And so after T years, so let's say I don't know how many years, now we can write our formula, which is going to be P, because that's the principal amount, the 1,000, 1 plus the rate, and what would the exponent be? Exactly. And so that's what this formula should be. So you guys see how that's incorrect, right? The formatting got screwed up, I think, when we printed these out. It should be P times 1 plus R to the T. Okay? And so now what I quickly want to do is just make sure that you guys can type this in. If you are not getting it, it's the screenshots for your calculator are off to the side here. Okay, but let's just talk about the setup. So example 2, $1,000 is my principal. 1 plus 8.7 is written how as a decimal? Good. And now T is 20. Okay? And so if we type that in the calculator, we should get exactly what we see over here. You're not going to have these little screenshots every day, but for some reason in this section you have it in case you aren't getting those calculations. So you should get $5,300, well, $5,303.85 if we round up to the nearest cent. Okay? So now this is the part that's not done for you, but maybe you guys can tell me. How much interest did I earn then overall? Say it louder. Yes, and how are you getting that? So take whatever you got in the account, subtract what you put in, which is $1,000, and this is how much extra you've earned. So that's the interest. Okay? So you'll see problems like that on MathLab and on the quiz or test that'll ask you, so what's your future value? And you have total amount of money, and then they'll ask you, well, what was the interest that you earned then? So you got to remember that you just subtract that from what you put in, what the principal was. Okay? Let's do 40 years. So for 40 years, calculation is exactly the same. What's the only difference though? Yeah, this 20 gets changed to 40. And now you're going to start to see that this starts to blow up pretty quickly. Because now we end up with about $28,000, 28,130.78 if we round up. Okay, that's a lot of money compared to just $1,000, right? And so let's talk about splitting this up. So over those 40 years, how much interest was earned? How much did I put in? 1,000. So we just subtract, and that means $27,130.78. So that's how much interest was earned in 40 years. Okay, and just the last 20. Well, let's take a look. The first 20 we've already figured out. The first 20 we had $4,303.85. So how would I find the second 20 years, or the last half? Subtract. Subtract what from what is my question. 4,303 minus the 28,000. Ooh. Yes, because we're talking about just the interest. So if we've earned a total of 27,000 and whatever, the first 20 years was only 4,000 and change. The difference will tell me what I've earned the last half, right? And so if I subtract 27,000 minus 4,300, whatever that is, help me out. It's 22 something. 22. 826.93. And 93? Okay. All right. So any questions on where these numbers are coming from? Okay. Part E, I think we pretty much did that. Let's just go on. Okay? I think it's pretty clear. First 20 years, you only earn about 4,000. The second 20, it's ridiculous compared to it. It's like $22,000. Okay? So, on to the next page. In fact, let's just do two formulas at once so we can talk about them. So, the second way that you can get compound interest is when you split it up over the course of a year. So instead of just waiting till the end of the year and then calculating it and then you get some money into your account, you can do, and these are the typical ways to do it, you can do things semi-annually, which means you get the interest split up into 2 times a year. Quarterly, hopefully you remember that that's going to mean 4. Okay. Weekly, makes sense, 52 times a year because there's 52 weeks in a year. Monthly means you're going to get 12 times a year you're going to collect interest. Okay, and then daily means that every single day you get a little bit of interest collected, and then that keeps getting recalculated. Okay? And that formula, so let's just go right to it. Here's what it should be if you cross this one out, because that formatting's off. It's principal 1 plus the rate divided by n to the nt. Okay, and if you ever forget what each letter means, everything's written right here for you. P is still principal. P is still principal. N is the only new thing that we got in here. N is the number of times compounded per year. So that's where these words come in. All of these are your N possibilities. Okay? When you see quarterly, that means N is going to be 4. If you saw daily, that means N is going to be 365. Okay? And so you don't really have to know necessarily where all the stuff comes from, but you should know how to use it. But, you know, being a math fan, I'm going to actually explain where this comes from and why this makes sense. So this represents the interest getting split up. Whoops, I put spit up. That's supposed to be split up. Okay. So here's what I mean by that. So let's say, you know, that 10% problem that we were doing. Let's say that instead of getting 10% once a year, that 10% gets split up into twice a year. Well, if you split 10 up into 2 pieces, how much is each piece going to be now? 5, right. So halfway through the year, you collect 5% interest, and then halfway, or another 6 months go by, you collect 5% more interest on what you already have.
So the R over N, what does it say on top of it?
The interest gets split up. I'm just explaining what, yeah, that's where that comes from. And the exponent here, this n times t, this actually represents the total number of compoundings. In other words, it's the total number of times that you collect interest. Okay, and so if we do that example below it, I think it'll make some sense. So example 4, we got a future, we're looking for the future value, so we want to know A. $1,500 is deposited into an account that earns 5.4 interest compounded quarterly. So it'll be 1 plus 5.4. How would I write that as a rate? 0.054. Very good. And we're going to divide that into how many pieces? 4. So that's where that part of the formula comes from. And now the exponent, well, that's just those 4 times that I'm compounding, but I'm doing 4 times a year for how many years? For 20. So that's the NT part of the formula. Plugging this in with numbers, does that kind of explain a little bit more of how that formula works? 4 times 20 is 80, so that means 80 times for the entire loan, or the entire, is this a loan? No. 80 times for the interest account, you collect interest. That's what that means. Okay? And if you type that in the calculator correctly, we should end up with roughly this amount right here. $4,385.22. Okay? If I did this for 40, same exact calculation. The only difference is that now instead of doing 4 times 20, I would do 4 times 40. And now we get what it says here, which is about $12,820.11. Okay? Any questions on that? Okay, so there's 2 formulas that we've done so far. We've done this one. We've done this one. Okay, and I'll add the third here in a minute. Let's go on to page 3. Yes, go ahead. So the third type of interest that you can collect is something that's collected continuously, continuous compounding. So rather than splitting it up, 52 times a year or 12 times a year, continuous means that you're getting interest nonstop. Every second, every nanosecond, every instant of every day, you're collecting interest. Okay? And you don't really have to know where that comes from, but here's an explanation that kind of explains what happens to that 1 plus R portion. Okay, so if we're collecting interest and we're collecting it nonstop, here's a table that kind of explains, well, if we collect it once, here's what that value really is. If we collect it nonstop, well, 1,000,000 times isn't really nonstop, but it sure is getting closer, right? And so if we collect interest 1,000,000 times a year, bless you, that little factor starts to get close to something that looks like 2.718, okay? And that symbol is E, okay? So that's something you need to remember now. E is about 2.718. It goes on forever. Just like you've gotten so used to pi, right? When you first learned pi, it's probably mysterious and you didn't really know how it worked, but now you know, what is that? 3.14 about, right? This is another commonly used number, and this is where it comes up with interest problems, okay? And here's the formula that we would use anytime you see compounding continuously. Again, the formatting's off here. It should be A equals P E to the RT. Okay? And so for example 6, I'm going to split this up into 2 separate parts just so that we can compare. So let's say for part A we do example 6 the way it says, but it's compounded not continuously, but compounded, let's do monthly for 5 years. So we can compare the formulas. And for part B, let's do exactly what it says. So example 6, exactly the way it's written. Okay. So for getting this new formula that we talked about, if we were doing interest getting split up monthly, right? I would use A equals P, which is 2,000 in this problem, 1 plus, what's the rate? 0.043. Compounded monthly is the key, so that tells me to split this up 12 times over a year. And my exponent will now be n times the number of years, which in the problem is 5. This one we're not going to cheat because it's not done for us. Go ahead and type this in and let's see what we get. All right, anybody got the total? What is it?
2,478.77.
Okay, seems reasonable. And you'll see why in a minute. Example 6, if I was actually doing this compounded continuously, now it tells me to use the other formula, the one we just talked about, P e to the RT. So if we plug in 2,000 for the principal, E, the rate is now going to go into the exponent, which is 0.043, and T was 5. So this is how it would look like if you type it in. When you type that in, that part was done for us, we get $2,479.72. May not seem like a big deal, but which one was a little more? Compounded continuously. That's always the best option. When you're only doing this for a few years, it's only going to be a little bit bigger. But if it's over the course of a longer period of time, that dollar and actually, what is that? Almost $1. Okay, that grows into a lot more money than just that. Okay. Any questions? All right. So tomorrow